Hello, welcome back to my channel. Today let's solve another Leetcode problem, number 77, combinations. Actually, this is a daily challenge from the Leetcode, so I'm trying to solve this first. The problem is straightforward. Given two integers n and k, return all possible combinations of k numbers chosen from the range 1 to n. In Python, we have the built-in library, we can use the combinations, but here we are not going to do like that because I'm going to use the backtracking to write the function. Yeah, basically my function will be like this. I'm going to write a backtrack function, and I'm going to call the backtrack. After call, I'm going to return my result. I'm going to have a global result array. Yeah. Now let me go to the whiteboard to finish the explanation, and then go to the code editor to finish the coding. Now let's go to the whiteboard to check what the problem looks like. Yeah, so basically when we are going to solve the backtracking of combination of 4 to 2, it means from number 1 to 4, we are going to choose two numbers and there is no duplicate. So how should we solve that? The first step is we should know this problem is about backtracking. Why should we know that? Because this is from math, we needed to choose something. And also we can check that n maximum is 20, k maximum is n. So it means like this kind of problem we can use backtracking. And also when we solve like permutations or combinations, normally we should use backtracking to find all the possible solutions. So this is the backtracking. Now let's go to the whiteboard. So if we are going to choose four numbers 1, 2, 3, 4. We just need to choose two numbers. Yeah. So the first step, there is an empty array. After that, we can choose 1, 2, 3, and 4. So this is the backtracking tree. And after that, for 1, we can choose 2, 3, and 4. We cannot choose 1 because there is no duplicate. What about 2? We can only choose 3. What about 3? We can only choose 4. So for 2, we can choose 3 and 4. And for 3, we can choose only 4. So this is the final result. But how should we use backtracking? We should use an empty array, like an answer variable inside the backtracking tree. And when we find an answer, we should put this answer into our final result. And then we're gonna return our result. Yeah. So how should we find this kind of a 1, 2, 3, 4? So this is basically a for loop. We can use a for loop to find its branch. And after that, we can still use the for loop for the backtracking tree. And what is this one? This one, when it goes to 4, we cannot choose 5. Yeah, because the maximum of the number is 4. We cannot choose 5. It means here there's nothing to return. There's nothing, we're gonna put it into our result. So this is all our result. Now let me go to the code editor to finish the coding. And after you see the coding, you will check. This is basically a backtrack template. So a lot of problems, if you did a lot of backtracking problems, you will find your pattern and your template. Normally it should be very easy for such kind of medium problems. Sometimes the hard problem maybe it's difficult to find each of the conditions. But for the medium problem of backtracking, normally it should not be so hard if you practice a lot. Yeah. So for backtracking, we're gonna put the variables inside. What is the variable? We are going to find. So we are giving n and k. So what is the starting point? The starting point is 1, 2, 3, and 4. So we're gonna have a starting point. The backtrack, we're gonna call this number 1. So what is this one? This one is our start point. I'm going to use a start variable. And also I need an empty array because I'm going to put this empty array into my result. So what is this empty array? I'm going to define a variable answer for this empty array. And then I'm going to write my backtracking function. So what is the conditions to return if we find one answer? So if the length of the array equals to, although this takes a little bit time, but it is still okay. We just check the length of the array. If this length is equal to k, it means we find an answer. So what should we do? We should just put the answer array into our result. And here we need a return to let it stop earlier. And then we should use our for loop. So for I in range, we should start. So for the I, we should start from this start, and the start is 1, yeah, and to n plus 1. Because for the first loop, for the first layer of the backtracking, we can only have 1, 2, 3, and 4. So what about here? So this I can only start from 1, 2, 3, 4. So this start is 1, this n is 4. So it means I will start from 1, 2, 3, and 4. And then we can use backtracking. So what is inside? So for the next one, as we know that from the whiteboard, let's check. So here is 1. So for the next one, it will be 2, 3, and 4. Yeah, here if it is 2, it will be 3 and 4. And then we can write our backtrack function for the next step. So it will be start from 1. Yeah, because it cannot have duplicate. And then we should have our answer. Our answer should plus this index I. Yeah, because for the next backtracking, we need to put this I. So we need to put 1, 2, 3, and 4 inside. It is totally like this, 1, 2, 3, and 4 inside. Yeah. And here we can just append the answers. Because here we used plus for the Python. It means a copy of the answer. We can just put it inside. If we use a stack, we have to append copy of the answers. Now let me submit it to check if it really works. After that, I will change it to stack. Let's check if there is something wrong. So here it should be, yeah, from the I, it's not start, because for each time, as you can see, if the backtracking from the start, there are so many duplicate, because for the next backtracking, it's not the start. Yeah, as you can see here also from the whiteboard, for the next one, there's not so many answers. Yeah, so it means it's not from the start. The start is from 1. Actually, it is from I, because for the first backtracking, I is 0. For the next one, it will be 1. For the first backtracking, the I is 1, but for the next, I should be 2. Yeah, for example, here, this is 1. For the next one, it is 2, and 3, and 4. So this is Y here should be I plus 1. Yeah. Now let me run it to check if it really works. Yeah, as you can see, it really works, and it's pretty fast. Now let me analyze the time complexity for this backtracking tree. As we know, the number of n is 20, and this is basically the depth of the tree. It is 20, and how many branches for, yeah. So the k should be less than 20. So for the combinations of, yeah, of 20 to a number, we should use math to calculate. Yeah, it is basically CNK. So the final result would be dependent on this combination of CNK. I believe that is the time complexity. Now let's try to use a stack. So if we can put the answers, append this I first, and here we should change it to answers because it has already been appended. After that, we just need to answers pop. Yeah, because we append an I. If we want to use the backtracking, go to the next one. If we didn't find, we have to pop it out. So answers should pop. Yeah. Now here should be copy the answers. Yeah. Now let me run it to check if it works. Yeah, as you can see, this also works. The only difference is here we just copy the answer result. Here we use the in place, we used this answer. Yeah, so basically it's the same. Yeah. Yeah, if we are going to analyze this kind of complexity, like this is say k, so it's really dependent on this n and this k. Yeah, so this is the time complexity to compare how many combinations. For example, this one 4 times 3 divided by 2, there are 6 results. Yeah, but if this n is like 20, yeah, if this k is like maximum k maybe 10, yeah, so the final result would be like um, yeah, the final result would be say 2010. Yeah, this may be the biggest number for the combinations. So the say 20, it means 20 um, factorial divided by, yeah, so if it is say for 2, it is 4 times 3 divided by 2. Yeah, so here will be 20 divided by factorial 10 and factorial 10. Yeah, it is a very large number. I didn't know about it, but this is basically the time complexity. Yeah. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. Bye.